Hi, welcome to Work Energy Power Assignment 3. To start off, I'm going to remind all of you again, there is no need for you to finish entire video on this assignment. Skip to the question that you need to and focus on them. Should you need to seek clarification, come and find me and arrange for a consultation. Okay, question 1a, state what is meant by power and state its SI unit. Okay, so the definition, I'm going to leave it to you. SI unit in this case is watt. All right, capital letter W. This is very important. Okay, so I just want to, this is not a definition, but I'm just going to break down the definition of power to you. So definition of power is the amount, all right, so simply put, the amount of work done in 1 second. In 1 second. This is the meaning of power. So if I have a wattage of, say, a power of 50 watt, okay, 50 watt actually means 50 joule of work done in 1 second. All right, I'm going to give, I will just give another example. If I tell you that my hair dryer has a power of 2,200 watt, what does that mean? It means that in every second, 2,200 joule of work is done in 1 second. So what does it mean that my hair dryer does 2,200 joules of work? Okay, so what kind of energy does the hair dryer take in? Electrical energy, right? So the fact that the hair dryer takes in electrical energy and eventually gives you something that you want, which is what? The kinetic energy, right? It has to spin the fan and then after that it creates some kind of wind, right? So that's the kinetic energy and the heat, all right, that is needed to actually dry your hair. And of course, hair dryer usually is not silent, all right? The quietest one is Dyson, even so, there is still noise produced. So there will always be heat, kinetic energy, and sound, all right, produced by the hair dryer. So when I say that 2,200 joule of work is done in 1 second, with reference to the hair dryer, it actually means 2,200 joule of electrical energy is converted to thermal, kinetic, and sound energy in every second. Okay, so that's the meaning of power. Okay, and this is a very important understanding. Okay, O level, they tend to like to ask what is meant by this power, what is meant by that work done. Okay, so you need to know. Okay, B. A man weighs 600 Newton. He runs up stairs of total height 600 Newton, height 4 meters, 3 seconds. So calculate power. So power equals to work done over time. All right. So work done is what? So this is the kind of formula that I need you all to be very good at. Okay, you need to put a formula within a formula. Remember the formula for work done? Energy times this force applied multiplied by distance moved in the direction of force, right? Force times D over time. What's the force? 600 Newton is the weight of the man. So in order for him to climb up, he must exert an upward force of 600 Newton, climbing up in a distance of 4 meters. All right, everything done in a time of 3 seconds. So it should be 800 watt. Yes? Question 2. When a force of 300 Newton is applied to a box weighing 600 Newton, the box moves 3 meters horizontally in 20 seconds. Okay, so calculate the average power. So let me highlight all the important things. A force of 300 Newton is applied in a box weighing 600 Newton. It moves 3 meters horizontally in 20 seconds. Calculate the average power. So let's write out the formula again. Power equals to work done over time equals to force times distance over time. So we are given two forces, 300, 600. When I push the box, do I look at the 300 Newton or the 600 Newton force? Of course, the 300 Newton force, because the distance moved 3 meters is in the direction of the 300 Newton force, not the weight. Okay, if it is moving in the direction of the weight, it means that the box must be dropping down. Okay, but this is not, it's moving horizontally. So equals to 300 multiplied by 3 over 20 seconds. So answer should be 45, is it? Yep, 45 watt. Okay. 3. A person exerts a horizontal force on a box that also experiences a frictional force. Oh, it takes 4 seconds to move the box 3 meters. Calculate the average useful power. So useful power, right? So maybe we draw a very simple diagram. So I exert a force of 600 Newton on the box. It has a friction of 200 Newton, frictional force of 200 Newton. So it moved 3 meters. So the thing is this, they only want the useful power. Useful power means what? Do I want to look at the entire 600 Newton? No, we don't. All right, we're not interested in the entire 600 Newton because out of this 600 Newton, 200 Newton is used to overcome the friction, which is considered the non-useful one because in the sense of pushing a box, a crate across the road, the ground, friction is always considered as unnecessary. Okay, we do not want the friction, but it's there. Okay, so useful force is only 400 Newton. Okay, so what we can do is 400 multiplied by 3. Okay, 1200 joule. So what is the power? 1200 divided by 4 seconds. Answer is 300 watt. Right? Okay. So let's move on to the next question. A girl weight 500 Newton runs up a flight of stairs in 10 seconds. The vertical height of the stairs is 5 meters. What is the average power? So very typical question, work done over time. Force times distance over time. So what's the force? 500 Newton, right? Multiplied by, she climbed 5 meters. And then it took 10 seconds. So this is, I consider a very kind question because they only give you values that you need. Then you can just straight away plug in all the values and find the answer. All right, 250 watts. Right? Simple. Question 5. The crane is used to lift a load of 1.5 times 10 to the power of 5 Newton from a height of 1 meter at S to a height of 25 meters at T along the diagonal path ST in a time of 30 seconds. So this is the kind of question that, you know, students hate because they have so many numbers. All right, so we need to internalize the values given to you. The load is 1.5. So to lift it up, you need a force of 1.5 times 10 power 5 Newton. All right, height of 1 meter. So initially it was here, 1 meter. Then it went up. This is 1. This is at 1, and at T is 25. So the height gain is not 1, it's not 25. The height gain is 24. Okay, so you see, this is what I meant by not all the values given to you should be used directly in your calculation. So if you actually miss this part, then the entire question will not be right. Okay, so I don't care if they use a diagonal path or what, okay, because the force used to lift up the load is a vertical force, right? Because the load give you the weight, so I'm talking about the vertical force. So I'm only interested in the vertical distance. So I don't care if it is moving diagonally or horizontally. I'm only looking at the vertical distance of 24. Calculate the gain in GPE as it's lifted to S to T. So gain in GPE, do not just put GPE. Gain in GPE is, what's M? I don't have M, but they already gave me the weight, right? A load of 1.5 times 10 power 5. So in this case, mg is weight. So it's 1.5 times 10 power 5 immediately, and multiply by height, which is 24.0. And then what do I get? 1.5 times 10 power 5 times 24. 360,000 joule. Okay. If the electrical energy is supplied to the crane, what is the meaning of this? Okay. Technically speaking, efficiency, we don't have to do, right? All right. It's actually out of syllabus. All right, but I'm just going to talk about this now. Okay. This means 5.3 times 10 to the power of 5 joule of energy in 1 second. Every 1 second, I supply this amount of energy. So how long was the engine operated for? The entire crane was operated for 30 seconds, right? Over here. So let's see. Energy supplied, okay, by the crane equals to 5.3 times 10 to the power 5 multiplied by 30. Okay, this is the energy, right, supplied by the crane in 30 seconds. Okay, let's calculate, multiply by, what is that, 30 seconds. So the crane actually supplied 1.59 million joules of energy in 30 seconds. However, what is the energy gain? To lift the crate up, so what is the energy gained by the load? Sorry, not the crate, the load. The load only gained 360,000 joules of energy, but the crane actually supplied 1.59 million joules of energy. So the question is asking for the efficiency, right? So efficiency is the thing that the useful energy divided by the input energy, all right, times 100%, right? I give you this amount, I give you this, I only achieve this, all right? So what's the efficiency? So it's 36, okay, divided by 1590. Answer is just 22.641%, 22.6%. Okay, so that's the meaning of efficiency. Okay, so at position T, the crane stops lifting the load. If the load is dropped from this height, calculate the speed of the load before it hits the ground. Okay, so now we're talking about conservation of energy. The load is now at height 24 meters. It drops at height, no, not 24, at height 25 meters. Okay, it's going to drop for 25 meters, right? So let's calculate first. Let's write out the formula first. Okay, change in GPE is equals to change in KE, right? So mgh equals to half mv squared. I think this part, all of us seen this already. So cancel the m. All right, the question wants you to find the speed, right? V. All right, gonna leave the manipulation to you, but this is how it's gonna look like, the final product, square root of 2gh. So what is 2? I mean, okay, 2 of course is 2. G is 10. What's the h? Is it 24? No, it's no longer 24 because the T, the load is now actually at 25 meters. The initially we used 24 is because that was the height gained by the load, because it wasn't starting from the floor, it was on a lorry. All right, that started from the lorry. So right now it's going to drop not 24 meters, it's going to drop 25 meters to reach the ground. So the height should be 25 here. Okay, 25.0. So let's calculate this. 20 times 25. I'm going to square root 500. Okay, answer is 22.360 meters per second. Roll it off to 22.4 meters per second. Okay, and that marks the end of this assignment 3. Okay, I thought this is a good assignment. All right, it really polish up and refine your calculation for this topic, and this is a very big topic which I need all of you to be really good at. Okay, so hopefully this assignment helps you in understanding better. If not, feel free to come and look for me.